Indefinite integrals. We are taking R.D. Sharma Solutions class 12th. Chapter is 19. Exercise is 19.21. Now if you see this question, it's an easy question, but it seems different from the question we have done earlier. So we know that the x square plus 1, if we differentiate, what are you going to get? 2x. X is already in the numerator. So we'll divide this numerator into two parts. That is, this integration will become like this, x and here plus 1. So I'm separating x and 1 and keeping the denominator here like under root x square plus 1 and here also under root x square plus 1. Now this is going to be integrated. This is dx and this is also dx. So what will be the benefit? We call it as the divide and conquer approach. So we divide the problem. If the problem is bigger, we divide it into smaller parts and then try to solve them. So this is the first one. We are calling it as I1. This one calling as I2. So this I1 will be, we have just already discussed it. So t, if you take x square plus 1, this dt by dx will be equal to 2x. That means x, this x dx will be dt by 2. So this x dx dt by 2, let's call it as dt, and half dt by 2, that is half will come in front, and under root x square plus 1 will be t, because x square plus 1 was taken as t. Now dt by under root t is directly 2 root t, 1 by 2 is already there, 2 gets cancelled, you have an under root t. Then a constant of integration, let's call it as c1. So what do we get? Under root x square plus 1 plus constant of integration. This is your I1. Now coming to I2, see I2 has a direct result. What is the direct result? Dx by x square plus a square under root. We have a direct result, log x plus under root x square plus a square inside the modulus sign. Same thing we are going to do here. I'm going to write the direct answer, log x plus under root, this is x square plus 1. Modulus cancelled plus constant of integration. This is C2. So this I will be, actually we have called it as I1 and I2. So we are going to add it up. I will be equal to I1 plus I2. What is I1? It's under root x square plus 1. What is I2? It's log modulus of x plus under root x square plus 1. And C1, C2 combined, we'll call it as C, capital C. So that's your final result which you are witnessing right now. So this is the result. As I was telling you that this question seems different, but it's easier than the previous questions we have done. So these kind of questions, as I was indicating you earlier, we have done, we have solved it. So don't worry if you don't understand up till now also. The last question we are going to take, it will be absolutely similar to what you are witnessing and seeing here. So those who want to do by themselves, this is the reference for them. So you can just refer this and then solve it. The negative x square inside a root below, that is in the denominator, we already completed that, and 2 or 3 questions we have taken. So I'm giving you the liberty to do it by yourself. Now this question, it seems different. So we need to do it, but you will see just by one algebraic change, we will get a very easy expression to be solved. So under root 1 minus x divided by 1 plus x, we always rationalize it. We multiply it by numerator and denominator with the sign which is opposite to the denominator. That is under root 1 minus x and 1 plus x. So we need to multiply both numerator and denominator by 1 minus x under root. Why do we do this? We will get the numerator without a root and the denominator will get 1 plus x and 1 minus x you multiply, you'll get 1 minus x square. This is root 1 minus x, root 1 minus x multiplied to the numerator and denominator. This is 1 minus x square, 1 minus x whole square, because you know 1 minus x under root is half, 1 minus x to the power half, 1 minus x to the power half gets added, half and half is 1. So you get 1 minus x to the power 1, which is 1 minus x only. How about the denominator? Under root 1 plus x into under root 1 minus x. So 1 plus x into 1 minus x, under root a into under root b is simply under root a into b. So 1 plus x into 1 minus x will be 1 minus x square, that is a square minus b square. So this 1 minus x square is in the denominator now. So this is your I, which is your actual integration which we are going to perform. So one of the questions we have just completed. So we will separate them out. That is 1 here, x here with a negative sign in between. Denominator will separate them out. So under root 1 minus x square in the denominator. Similarly, 1 minus x square in the denominator here also. Now we have a direct result here. I1. I2 is this one. So let's complete the I1 first, because we know the direct result is simply integration of dx by under root a square minus minus x square. A is 1 here. What I'm trying to suggest here is integration of dx by a square minus x square has a direct result which we already know. So this will be sine inverse x by a. X is x, a is 1. So let me write the direct answer, sine inverse x by 1, which is sine inverse x only, plus a constant of integration. This is I1. Now let's go to I2. What is I2? X by under root 1 minus x square. So this is 1 minus x square. If you take this 1 minus x square as t, dt by dx will be what? It will be negative 2x. That is dt minus 2 will come here, so it will be negative dt by 2 equals to x dx. So this integration, the first integration and the second integration, this is x dx, and x dx now here can be replaced by negative dt by 2. So this will be minus half you can take outside, and dt will remain inside. Under root 1 minus x square was already taken as t, so under root t. This is under root t, and we know the direct result of this. Negative half dt by under root t is twice of under root t plus constant of integration. 2 gets cancelled. It will be negative under root t was 1 minus x square plus constant of integration, which is c2. So I1 and I2 we got. So basically we have to do I1 minus I2. So this I will be I1 minus I2. What was I1? It was sine inverse x plus a constant of integration. This C1 and C2 constant of integration of both the I1 and I2 we are going to combine and call it as a capital C. So this is sine inverse x, minus already there. So minus minus will become plus. And then we have under root 1 minus x square plus constant of integration, C1 and C2 added up. So this I which you see is your final result. Alright, I1 minus I2 we have done. So how are we going to do this? As I have explained you in the entirety, but those who want to do it by themselves, this is the result. The basic thing is the rationalization, and will make your things easier. Again, these are all the questions which we have already done. You know the way, but don't worry, the last question is exactly like this one, and that I'm going to solve. So in r.d.sharma, you will see question being repeated just for you to get a good practice that even any question which comes in the question paper, you are able to solve it. So this is the reference which I am presenting. Any problem, just let me know in the comment, and we are going to solve it again and again. Same thing here, no change at all. The process or the theory remains the same. Again, same thing, because we are going to do this kind of questions in a while, because there are various questions I am skipping, and that is not good. And these are the references which I am providing you. If you are stuck anywhere, you can get help from these references. So as I was promising you that we are going to do this question. Those who want to do themselves, this is the reference for them. They can go ahead, but let's do it. So if I skip it, there will be subscribers that they will get angry. So I don't want that to happen. But I will, if I'm doing it, I will initiate or tell you a different concept also. That concept you will just see what will happen. I just showed you in previous question. It can be easily done without any further explanation, but you will see that one thing, there will be somewhat different thing which I am going to place here. You already know x square plus 2x plus 3 to be differentiated. It has to be represented in the form of x plus 2. So x plus 2 is a into d by dx of this x square plus 2x plus 3 and plus a capital B. This is, what is the differentiation here? X square is 2x plus 2 and then B. This is x plus 2. Same thing we are doing. We are multiplying it now. So 2ax plus 2a plus b. This is equal to x plus 2. And we will equate the similar terms. Similar terms means those terms containing x are to be equated. Those constant term has to be equated like this. So 2x equals to x, and 2ab, there is no constant term on the left, there is a 2 on the left, so we are equating it to 2. So a is 1 by 2 here. If you place a here, 2 into 1 by 2 plus b is equal to 2. This gives you b equals to 2 minus 1. So b is 1, a is half. Now this is the actual equation where we try to represent x plus 2 in certain form, which makes the equation easily integrable. So I becomes like this. Half is a, 2x plus 2. The denominator remains the same. So I'm now putting this integration sign after doing all this simplification. Under root x square plus 2x plus 3. What is b here? It's just 1, so don't worry, it's just dx divided by, let's introduce an integration sign now. So dx divided by under root x square plus 2x plus 3. So this is also having a dx. We are calling this as I1. We'll call this as I2. So this I1 will be what? X square plus 2x plus 3. We know that if we place t equals to x square plus 2x plus 3, this dt by dx will be equal to 2x plus 2, which we have already done in the equation 1. So dt will be equal to 2x plus 2 into dx, which is the numerator of I. This one, I1 actually. So I1 numerator is dt. Half is already there outside. Integration sign. And then we have x square plus 2x plus 3, which is t. So you just write under root t. So this is direct result. So just call it as 2 under root t. Half is already there. 2 gets cancelled. Under root t plus constant of integration c1. So the final result will be, what is under root t? T is x square plus 2x plus 3, which we initially took, plus constant of integration, call it as c1. I1 we have already done. We'll compute I2, combine them I1 and I2, and then finally get the I. What is I2 now? Now this I2 is x square plus 2x plus 3. We have to make it as a perfect square. So x square plus 2x plus 3, what is the coefficient of x? Coefficient of x is 2. So divided by 2, you'll get a 1. And then square it. So 1 square. That will be 1 only. So add 1 and subtract 1. So we are adding a 1, subtracting a 1. So a square plus b square plus 2ab, which is x plus 1 whole square. How about 3 minus 1, which is 2? So plus, you can call it as under root 2 whole square, because we have to make it as a perfect square. So under root 2 whole square. So this I2 will become like this. We don't have any constant here. Dx by under root x plus 1 whole square plus under root 2 whole square. So here I want to introduce that thing which I was telling in the beginning of this question, that I directly write the answer, tell you that, oh, this is dx by under root x square plus a square. Remember, dx by under root x square plus a square has a direct result, log x plus under root x square plus a square. You already know that. But the question which can arise is why you are writing x is x plus 1. Is it not x plus 1 and x different? Yes, I agree with this. But just you will see that if you take x plus 1 as say some u, that is, if u is x plus 1, you just differentiate it du by dx, this is going to give you 1. Because differentiation of x with respect to x plus 1 with respect to x is 1 only. So du becomes equal to dx. So there is no change. But still we'll apply this u. So let's write the answer. You know that this we have taken as u. So u square plus under root 2 whole square or x square plus a square is same. So log u plus under root u square plus root 2 whole square we are writing. Alright. Now what is u? It's x plus 1 only. So that is log x plus 1. So initially the 17 question we have completed the same thing we have done. Log x plus 1 we have written only. And from where this u square, that is x plus 1 whole square plus root 2 whole square has come? From x square plus 2x plus 3 only, because we have added 1 and subtracted 1 by ourselves. So you can just write x square plus 2x plus 3. So that is why I am always keeping this u content or u step, because it doesn't matter. Du always equals to dx plus a constant of integration, which is c2. So this I2 has already come, and now combine this I1 and I2 together, and that is going to be I. Final I is I1 plus I2. So this I is going to be equal to I1 was what? Under root x square plus 2x plus 3. C1 and C2 will call it as C. This is log modulus of x plus 1 plus under root x square plus 2x plus 3 plus constant of integration, which you call it as C. From here to here, it's your final answer. Okay, this is the final result. And in this solution, you will see I've also added up that u equals to x plus 1 just to show you that the result remains unchanged even if you follow my scheme or this scheme. Alright, so just all these questions have the same way of solving. So this is all about this exercise. I hope you got a better idea of this exercise. Have a good one. Take care.